We've seen that even though Pandas allows us to iterate over every row in a data frame, this is generally a slow way to accomplish a given task, and it's not very Pandorable. For instance, if we wanted to write some code to iterate over all of the states and generate a list of the average census population numbers, we could do so using a loop and the unique function. Another option is to use the data frame groupBy function. This function takes some column name or names and splits the data frame up into chunks based on those names. It returns a data frame groupBy object, which can be iterated upon, and then returns a tuple where the first item is the group condition and the second item is the data frame reduced by that grouping. Since it's made up of two values, you can unpack this and project just the column that you're interested in to calculate the average. Here are some examples of both methods in action. Let's first load the census data, then exclude the state level summarizations, which had a sum level value of 40. Here are some examples of both methods in action. Let's first load the census data, then exclude the state level summarizations, which had a sum level of 40. In the first, we use the census date. We get a list of the unique states. Then for each state we reduce the data frame and calculate the average. If we time this, we see it takes a while. I've set the number of loops here, the time it should take, to 10 because I'm live coding. Here's the same approach with a groupBy object. We tell Pandas we're interested in grouping by the state name, and then we calculate the average using just one column and all of the data in that column. When we time it, we see a huge difference in the speed. Now, 99% of the time you'll use groupBy on one or more columns, but you can actually provide a function to groupBy as well and use that to segment your data. This is a bit of a fabricated example, but let's say that you have a big batch job with lots of processing, and you want to work on only a third or so of the states at a given time. We could create some function which returns a number between 0 and 2 based on the first character of the state name. Then we could tell groupBy to use this function to split up our data frame. It's important to note that in order to do this, you need to set the index of the data frame to be the column that you want to group by first. Here's an example. We'll create some new function called fun, and if the first letter of the parameter is a capital M, we'll return a 0. If it's a capital Q, we'll return a 1, and otherwise we'll return a 2. Then we'll pass this function to the data frame apply and see that the data frame is segmented by the calculated group number. This kind of technique, which is sort of a lightweight hashing, is commonly used to distribute tasks across multiple workers, whether they're cores in a processor, nodes in a supercomputer, or disks in a database. A common workflow with groupBy is that you split your data, you apply some function, then you combine the results. This is called split, apply, combine pattern, and we've seen the splitting method, but what about apply? Certainly, iterative methods, as we've seen, can do this, but the groupBy object also has a method called ag, which is short for aggregate. This method applies a function to the column or columns of data in the group and returns the results. With ag, you simply pass in a dictionary of the column names that you're interested in and the function that you want to apply. For instance, to build a summary data frame for the average populations per state, we can just give ag a dictionary with the census 2010 pop key and the numpy average function. Now, I want to flag a potential issue in using the aggregate method of groupBy objects. You see, when you pass in a dictionary, it can be used either to identify the columns to apply a function on, or to name an output column if there's multiple functions to be run. The difference depends on the keys that you pass in from the dictionary and how they're named. In short, while much of the documentation and examples will talk about a single groupBy object, there's really two different objects, the data frame groupBy and the series groupBy. And these objects behave a little bit differently with aggregate. For instance, we take our census data and convert it into a series with the state names as the index and only columns as the census 2010 population. And then we can group this by index using the level parameter. Then we call the ag method with a dictionary that has both the numpy average and the numpy sum functions. Pandas applies those functions to the series object, and since there's only one column of data, it applies both functions to that column and prints out the output. We could do the same thing with a data frame instead of a series. We set the index to be the state name, we group by the index, and we project two columns, the population estimate in 2010 and the population estimate in 2011. When we call aggregate with two parameters, it builds a nice hierarchical column space, and all of our functions are applied. Where the confusion can come in is when we change the labels of the dictionary we pass to aggregate to correspond to the labels in our group data frame. In this case, Pandas recognizes that they're the same and maps the functions directly to columns instead of creating a hierarchically labeled column. From my perspective, this is very odd behavior, not what I would expect given the labeling change, so just be aware of this when using the aggregate function. So that's the group by function. Now I use the group by function regularly in my work, and it's very handy for segmenting a data frame, working on small pieces of the data frame, and then creating bigger data frames later.